Welcome to the last individual assignment. This is the final project. My name is Christian Nevia, and I'm here to present my presentation for the CIT 260 course. This the final assignment. So to start this presentation, we are going to explain the differences between a static class variable and a class non-static instance variable. The static class variables, are unknown, so known as a static member of the variable. So it will be one of the characteristics of this is that they will only have one copy of that variable, but it will be shared with all instances of the class. In this example, for example, we are creating this variable barcode with a data type int, and it's a static one. So any change that we made to this variable, all other instances that call to this variable, they will see the same changes. In the other hand, for the instance variables or non-static variables, these variables belongs to the instance of a class. It's not to a different class. So it's thus an object, and every instance of the class has its own copy of that variable. So the changes made to the variable don't reflect in other instances because that object, belongs to one instance of each class. So to view that as an example, we are going to our our Slayer game, our main class Slayer game. So every time we create it, here we have two examples of two statics variables, game and player. So every time we create a new game, we're going to call the variable game and player to create a new one. So for that we go also to the class game. So every time we call create a new game, we're going to call to the class game, and every time we call to the class game, it will create a new instance of a game. So every time a new instance of the game is created, it's going to create these variables for it. This is an instance variable. A game is an instance variable. It's a non-static, and it's the same as the player. Every time we create a new game, we are going to call the class player, and we are going to create these instance variables for the instance player. So this will happen, and to see as an example, we're going to the game control. So every time we create a new game, we are going to call the class game, and we are going to create an instance of the game, and we are going to assign the variables of the game class to the new game. So in this case, we are calling also to the instance variable Slayer game, and we are setting the current game to those variables. So to continue on the presentation, we are going to see the differences between an array list, and an enum. Basically, the difference, most of the three of them are used in Java, but as an example, an array is one of the native data types supported in most of all programming language. An array is used to model a fixed length list of objects or primitive values. These primitive values can be byte, short, int, long float, double, a boolean, or a char. All of the objects in the list must be of the same data type. So the elements assigned to each position in the list may be changed at any time. So each element in an array is referenced by an index. In an array list, in Java, is implemented as a class. It's not only as a list, it's a class. So it's a variable length list of objects. So this means that you can dynamically add and remove objects from that list. But these objects in the list may be of different data types, but primitive values, as an array, cannot be directly put in an array list. They must be converted into an object first. And then we have the enum. An enum is a special type of class in Java. Like an array, it has a fixed length and all of the elements in the list must be of the same data type. It may be a list of objects or primitive values, unlike an array, and the elements stored in an array cannot be changed, so they are constant. The elements in an array are not referenced by an index. Instead of that, they are referenced by a keyword. The keyword maps to a specific element in the list, so that's a characteristic, and a special characteristic of an enum. So you may have a question when you're going to use an array or an enum or an array list. Even though that an array list can be more flexible than the three of those types, it has one counterpart, that an array list, use memory dynamically allocated each time an object is added or removed from the list. So this is a very high CPU demanding, as an intensive operation, for the CPU. So most of the time, and also we did in our game, for a matter of performance, we most of the people use an array and an enum, and also it's more flexible, to use it, and it's efficient in the use of the performance perspective, because of the number of items in a list are fixed. So we are going to see an example also in our game, how we use an array and also an enum. So for that we're going to see the item. In here we're going to start with the enum. So now we have the item model. So in the item model we have the enum list, and we have 5 items in that list. Red ID card, police baton, medkit, blue ID card, and security armor. So in this case, we are using an enum list, and it has a fixed list, and this the ID of the object, of the item name, it's the same object. So we're going to see how we call this. When we create an array, we create an inventory list, and we are calling to the inventory item array. So every time we call to an inventory item array, we're going to call, and we are going to see that we have an array of 5 items. So when we call to the inventory item array, we're going to call to the item model, to the item enum that we have, and we're going to call the object, the item, that it's in this case red ID card, as an ordinal, and the reference of that item, it will be the same name of the object, in this case red ID. And in this array we have 5 objects. Those 5 objects are listed in the item enum. So this is an example of an array list, and how we use it to call, and how we use it in our game. So in this case we are going also to continue on showing how we use how we handle this kind of errors, and how we handle the throws of an exception in the game. So we are here in game control. So every time we play the game, we have the option, and we include it also in the save game, because this is an opportunity that the user has to operate the game and can see if we have a problem or not. So we added the throw an exception, and it's called game control exception. It's an IO exception. So every time we call the game control exception, we try and we get the error. We output stream that exception, and we show it in our game. So one of the way we throw and propagate that is that if an error occurs, we catch that exception, and we throw it that in the view error get message. For that we are going to go to the view uh, to the view of the game, and we are going to see that when we have an exception, for example here, every time we have an exception, and this it will be linked to the throw of an exception, and how we handle, we're going to call to get the message and throw it and write it down in an object. So for this, when we do this, is we catch the exception, we get the error from the game, we present it in the console game, and we throw it as an error. This is something that we do when we save the game. So every time we save the game in the console, we call it to that function, and we have a try. We throw an error, and if we catch it, we catch that exception, and we display it in the main menu view, in the console game. So for that, we are going to demonstrate in the game as an example, very quick. So if we want to save the game, and for example, it will show that enter path file for save. If we passed any save the output path and we save it, it will say that, because we pasted it when we were making the presentation, we pasted, it will save that file. And if we want to test it again, we will see that if we put our name and we want to save the game, we give in a path, for example, users Christian desktop output txt. It will show an error because the output path is not valid. Is not valid on the option that we have. So this is basically an example how we handle the throw an exception in the game. We are going to continue explaining in this presentation the differences between a character stream versus a byte stream. In the beginning, we're going to start for byte stream. In the beginning, in Java, the reads and writes binary data streams, it will be from 1 byte at a time in a sequential order. So byte streams can only read and write ASCII characters. Since they only store 1 byte of data and are only used for Western languages, it will happen that it will read only 1 byte at a time. But however, in Java as a default, Java would store data using Unicode format, so which stores 2 bytes of data. So basically, what happened in the later versions of Java, they created a way to handle the issue of Unicode characters formats, allowing to read and write the data regardless of what format data was stored. And this is considered the recommended approach for all I/O streams nowadays. So this is basically a difference between a character stream and a byte stream. Also, we are going to demonstrate in this class, we're going to see an example of the code that I write in my individual assignment. So my last individual assignment, one of the things I did is I wanted to add the same way as we have the inventory item. I wanted to add the guns enum list, as an enum list, and call it with from an array, and the array is going to be the firearm item, and I wanted to call the firearm items, and for that I use the guns control. So for the guns control, we use an array to call each of the current gun. So every time a person will need to use a gun, it will call to the gun enum, and also to the public class, to the class firearms. The public class, the class firearms it will has the size and everything information about the arm and the item of the gun. It will just said if it's found or not through the variable, and if it's used or not in the guns control mod control. So in the guns control, every time the user we use, if the case of the scenario has to use a gun, it will call and point out to the item firearms, and in this case, it will call to the object guns, and it will call to the bazooka, and in an ordinal. And if the user found that in the game during the game, it will point that to true in the case. It has to be the case 4, the 7, 8, 16, and 18. Since we have 14 cases of scenarios in the game, 40, no, not 14, 40 cases, it has many options to see it. This is not yet implemented in the game, because right now for the game, in the game control function, we are using the inventory item array to work in the game every time we create a new game. So, but it was an idea to add it as an inventory. Instead of using one item or weapon, we wanted to include also another type of weapon as guns in the game, to work with it as a weapon in the game every time a user founded one, and just to solve one part of the story of the game. To demonstrate the game, we are going to see right now that we are in the part that the game is not finished 100%. So when we enter the game, you have the options to new game, save game. We already tested the load game. It will call successfully to the function that the game it's load. So if we go back to the game and we want to know how to play, it will show an example of the message how to play the game. If we want to exit the game, it will quit the game. So basically the functions of the game are working, in the main idea. So if we start a new game, it will show up the message and the story of the game, and it will tell you that you are in one scenario and you need to choose. So in this case, we're going to go through the window, and it will point that that part of the scenario is not yet implemented. So if we go through the door, that it will point to the scenario 3, but it's not working yet. So the only part that we have in the game working right now is the go through door. The first scenario and the second scenario, and it will call you to go to a place. So if we go to the 5, go through the staircase down, it will not do anything. If we go to staircases, it will not do anything, because neither of the next scenarios are working. But basically the game is working. We were adding functions, and it will point out that the second scenario will point out to the scenario 5 is not yet implemented yet. So this is basically our game, and this is part of all the presentation that we did. My name is Christian Navy, and this is for CIT 260.